Welcome for mathematics lesson. We're going to discuss construction and locus. Using a ruler and pair of compasses only, construct triangle PQR in which PQ equals to 7 centimeters, QR 6.0 centimeters, and angle PQR is equal to 60 degrees. Then we measure PR. Let us do up to that point, then we continue reading the question. I will start by constructing the line PQ, just a straight line. So what I will do to this straight line is that I'm going to make a mark here, and I call it P. Then I use my compass to measure from 0 up to 7.5. Yeah, up to 7.5 exactly. Then I transfer that arc here. Now this is going to be my 7.5 centimeters, and I will call this point my Q. Something else to be measured is the length from Q to R, which is unknown where it is, but we are sure it is 6 centimeters. So we can measure the 6 centimeters. Can measure the 6 centimeters. Then with the arc of 6 centimeters, we just make the arc here, starting at Q, we make an arc. So because these are 6 centimeters from Q, anywhere along that arc is going to be our R. The other thing to do is to construct the angle at Q, because PQR equals to 60 degrees. Therefore, I'm going to construct 60 degrees at Q. Therefore, standing at Q, I'll make an arc. Then standing on where the arc has cut my line, I make an arc using the same radius to cut the first one at a point there. When I produce a line now through that intersection of the arcs, I'll get my 60 degrees exactly. And now the intersection of my 60 degrees and the 6 centimeters line will give me point R. So this is going to be point R now. Therefore, I can join R to P. This is P. Yes. So now something else we are told to do is to measure the length of PR. Therefore, I will stand here and I take the arc length from P to R exactly. Then now I will lift the whole of this length, place it on my scale, and identify that distance. So it's going to be 6.8 exactly. So this is going to be 6.8 centimeters. 6.8 centimeters. Now we continue interpreting our question. The second part, we are told on the same side of PQ as R, determine the locus of point T such that angle PTQ is equivalent to 60 degrees. Angle PTQ equivalent to 60 degrees. Therefore, there is a T somewhere such that PTQ, remember T should be on the side where R is equal to 60 degrees. That is now the constant angle loss. And using the properties of angles in a circle, we're supposed to know that for us to construct a circle whereby we can project an angle of 60 from a given line, then from the same given line, we are supposed to be able to project a line, to project an angle at the center of the circle, which is equivalent to double the angle at the circumference. Therefore, if at the circumference we need 60 degrees, then we should have 120 at the center. For us to have 120 at the center, then the base angles are supposed to be 30, 30. Therefore, we should have base angles of 30 degrees, 30 degrees, such that when we produce those angles of 30, they are totaling to 60. We're going to have our 120, and we use this one as a center to draw a circle locus. Now in this case, if this arc or this chord PQ is able to project 120 here, then it will be projecting 60 degrees at the circumference. Therefore, I'll begin with the base angles of 30, 30. The first 30 will just be a bisection of the 60 we already have. So I bisect this 60 now to produce 30 degrees. Then I do the same on the other side. I also bisect this. I construct a 60, then I bisect it. So I'll make that arc. Then using the same radius, I'll stand here to cut that arc. Then now I'll need to bisect now this 60 because this is now 60. So I'll make an arc. Then standing here, I cut that particular arc. Now I'll have bisected my 60 and I can produce my 30 comfortably. So standing here, I'll need to bisect this 60 through that intersection of arcs. Therefore, this is going to be 30. This is going to be 30. This is an indication that now we have made a 120 at that point. Now with 120 at that point, I am going to use this one now as a center to draw my constant angle loci. So standing at P to join at Q, I'll have my constant angle loci. Constant angle loci. So that is how we construct it. The constant angle loci on one side. Then the other thing we've been told to do is, okay, any point here is our T now, because any point using PQ, we're going to project 60 degrees. We are told again to construct the locus of M such that PM is equivalent to 3.5 centimeters. So from a point, the locus of a given distance is a circle of the given distance as the radius and the given point as the center. So using center P, we will draw a circle 3 centimeters, 0.5. 3 centimeters, 0.5. Therefore, anywhere from P to this circle is 3.5 centimeters. And now the circle becomes our locus of point M. So anywhere on this circle is point M. The circle is the locus M now, because anywhere there we have 3.5 centimeters from P exactly. The next thing, identify the region W such that PR is greater than or equal to 3 centimeters. PR is greater than or equal to 3 centimeters. So PR to be greater than or equal to 3 centimeters means we are going to have from P 3 centimeters length along PR. That means we will stand at 0 mark. I measure 3 centimeters. Then now standing at this P, I make a point. Now on this point, from this point onwards, PR is greater than 3 centimeters. From this arc now, which is 3 centimeters. But before this one, PR is less than or equal to 3 centimeters. Therefore, I'm going now to draw a locus of a perpendicular line through this point. Therefore, I will stand at that point 3 centimeters from P, and I construct a perpendicular. So I'll make an arc, I'll make an arc, and on the other side I do the same. Then I extend my radius to stand there, make an arc, then stand on the first arc to cut the other one, and through this point I draw the intended locus. Therefore now, using this line now, we can say beyond this line, I've shaded the unwanted side because it is beyond the line where PR is greater than 3, but before the line PR is less than 3. Then now we are also told to mark a region W where PR is greater than 3. So this side PR is greater than 3. When we continue, we realize that we also need the region where PTQ is greater than or equal to 60. Anywhere beyond this circle, PTQ is going to be smaller than 60. From PQ, projecting an angle beyond the circle, we are going to be having an angle smaller than 60. So what we're supposed to do is to say that for the angle to be greater than or equal to 60, it should be either on this circle T or inside. So this region now becomes unwanted. This region becomes unwanted. Remember, we are identifying by shading the unwanted region. Therefore, beyond the circle, it's unwanted. Before this line, it's unwanted. Therefore, the region W is going to be now anywhere inside here. This is our region W.